Hi, good morning, everyone. I'm Nigel Mbayak here, Application Engineer at Katif Technologies. I'm joined by Alex Alvarez, who's one of our Fusion AEs as well. So good morning to you all and welcome to Fusion Fridays. It's a little weird for me to say that. I'm used to saying Autodesk Virtual Academy, right? So, so today we're going to be going over something really interesting in Fusion 360, which is the creation and how to work in assemblies. For those of you who are coming from a traditional CAD tool, maybe SolidWorks, maybe Inventor, the way that Fusion builds these assemblies and how all of these, what we would call normally constraints and joints and mates are created are a little bit different than we're accustomed to. We want to make sure everyone starts on the right foot in regards to getting that process correct the first time. It does take a little bit getting used to. I'm sure Alex will talk to you about that. But once you get a hang of it, it's pretty straightforward. If you do have any questions at any point during the webcast, go ahead and type them into the GoToWebinar chat panel at the bottom of your screens at any time. And we'll go ahead and answer those at the dedicated Q&A section at the end. If you may notice, usually there's 3 of us on here. Brian Monkolpensek decided to go to Europe after graduation. So Brian, if you're watching us, Brian, hey, and hope you're enjoying your vacation. We'll see you here soon. But with that, I think let's go ahead and get started, Alex. So if you want to go ahead and just run through the presentation.
Yeah, thank you for that, Nigel. So like he stated, today's topic will be about assemblies. So like he mentioned, if you are coming from a different CAD software, you may be accustomed to creating the mates and then removing the degrees of freedom one by one until you get the range of motion that you're looking for. So Fusion 360 does take a different approach at assemblies in the sense that when you create a mate or when you add a joint, you're essentially going to tell it the degrees of freedom that it's going to have, right? Or the range of motion that you want that part to have. Now, like he said, it does take some time getting used to, but once you do get the hang of it, assemblies do become a lot quicker. So we take a look at some of the goals that we have laid out here. You may or may not already know that multiple part files are no longer needed, right? So you do have the ability to do multi-part modeling. In the short, that means that you don't need all these different files to have for the different parts that you have created. So now you can have all the parts that you need in one single file.
Right, and just to kind of elaborate on that a little bit, it's similar to an Inventor and SolidWorks and things like that. I like to think of it as bottom to top modeling, where you're modeling all of the part files separately and combining them at the top at the assembly level, which is what we're generally used to, right? I know that's how I learned, that's how you learned in school as well, right? Fusion takes a little bit differently, and Alex will show you that within that large environment, so essentially you're going to start with a component environment, you're going to be adding more components to that environment, more of a top-down approach.
Right, so now with the ability to do that, you do have to make sure that you know the difference between a body and a component, right? So if you were to get these two mixed up, you would have problems further down the line in the assembly. Now you also have to understand joints. So joints are really, if you're coming from SolidWorks, let's say, right? So instead of doing mates, you're going to be doing joints. Now there are 7 different types of joints that Fusion 360 has, and we'll kind of elaborate a little bit more on the different joints that it has. Then finally, we'll create a component using the existing geometry of your assembly, and then we'll show how we can save that part that we just created or that component and then use it for future reference.
Certainly, yeah. I just want to go over the vocabulary a little bit before we get started because it is a little bit different than maybe what we're used to using something like Inventor or SolidWorks.
Right. So then I guess the main thing that helps me distinguish a body and a component is that a component, you can think of it as a real world part, right, that has some sort of motion. Now it doesn't have to have motion, right? So if we take a look at a hydro flask, for example, just looking at it, you can see that it has maybe around 4 components, right? So it has the main body of the hydro flask, the cap, the handle, and then the pin that connects the handle to the cap, right? So then that's how you would split it up in Fusion as well. You would have a separate component for each of those parts. Right, so then here we have what's called a glyph, right? So when you're going to be ready and create your assemblies, when you add the joints or the joint origins, as they're also known as, you'll see that they're represented by the circle with the semicircle in the inside of it. And the way these work, right, if we go to the next slide, you'll see that they are similar to, I guess you can think of it as a plane. So when you add a joint to it and you select, let's say, the cylinder to this box over here, you see how the final result is going to give us this, right? But if we add or create an origin, a joint origin, when it's vertical, and again we do the same joint, right. Notice but if how we add our orientation or create an origin, changes. A joint origin, right? So then that makes the orientation of the glyph extremely important, and that's just one thing to keep in mind when you're creating your assemblies and going about it.
Generally, yeah, it's a lot different than selecting the edges and being, hey, this edge is perpendicular to this face. It's a different way of doing it, but I think at the end, it's faster.
It is a lot faster, right? Okay. So then jumping over here onto Fusion, notice that we have a couple parts over here scattered around. So then first thing to note too is that we have the main assembly active, right? So if you notice here, there are no bodies within this main assembly. And then we have the components over here represented by different colors. So now if you do want to make it a little bit more visually appealing for you, right, or easier to distinguish these different components, if we go over here under the Inspect tab and turn on Component Color Cycling Toggle, you see that now each component has its own unique color, right?
Yep. And if you want to explain here real quick, Alex, before we move on, the bottom line, which is that timeline, for your design history and the colors that are associated to that, if you want to explain those colors real quick.
Right, so each color is associated with the design history over here on the bottom right. So if we go ahead and take a look over here, we see that if we click on this component, it's everything associated with it is going to be under this certain, I guess, location, right? Or this section of the design history. So I guess going back to the advantages and disadvantages of this, I guess if you know, depending on the workflow that you're accustomed to, if you do have multiple parts in this, you will have a pretty large design history. But I guess the advantage to it is having the colors that help you distinguish, right, which belongs to which component.
Exactly.
Okay, so then going over here then, starting off with an assembly, you have to tell it which part is going to be grounded or which one is going to be pinned to the ground, or whatever isn't going to have some sort of motion. So then looking at this, we see that this base is going to be our fixed component. So to go ahead and ground it, right click on it and then make sure that it's grounded. Notice how we get this pin associated with the component as well. That's telling us that that's not going to be able to move. So if you see here, the other components are now allowed to move freely while the base stays still. Okay, so now looking at this, we can go ahead and create a joint here. So you can either go over here to the top, assemble, and then do joint, or you can press J for joint, capture the position. And then the way I like to think of this is the first part that you click on, or the first component that you click on, is the one that's going to be doing the moving to the fixed component, right? So let's say we want this part to move to the center of this pin or this hole, right? So then if we try to hover over to the center, notice how it moves. To keep those joint origins locked, go ahead and hold Control if you're on Windows, or Command on the Mac, and then notice how they stay locked right in place. So going ahead and clicking on this, we see that we get a joint type. So then going over to the joint types too, notice that we have several options to pick from. Revolute is the one that I'm actually looking for in this case. But notice how easy that was, right? If you were coming from a different CAD software, maybe you would have done a concentric mate on this, and then a width mate if you were to find the center of that. And this you only needed essentially just one click to get those two jointed together.
Yeah. Similarly, if you are coming from Inventor, this is probably pretty similar to you in regards to using joints versus constraints. If you're you can generally use one joint to get rid of it, even in Inventor. As well as Fusion, you can usually use one joint to get rid of multiple constraints, if you know what you're doing.
Right.
So
all right, so then moving forward here, then capture position. Next, let's go ahead and do this rod inside this hole over here. So then notice how this time we don't have to really click on any joint origin, so we can just click on this And then our second component is going to be this one right here. So notice how it remembers the last joint that we did, and it was revolute. Let's go ahead and do a cylindrical joint though. And that allows it to translate in this axis and then rotate about the y-axis. So let's go ahead and click OK. Right, so now let's go ahead and link these two together. So then, again, pressing J for joint, selecting the center of this. So we want the center of that, right? And then we are going to want the center of this as well. So notice how if I hover somewhere over here in the middle, I don't have access to that joint origin. Now you can either go ahead and create a new joint origin, or you can right click, select between two faces, right? So now it's telling us to select the two faces that we want a joint origin in. So we hover over here. Notice that we see the joint origin appear in the center of those two faces. Again, hold Command or Control to keep it locked and go ahead and click on it. Notice again that it's a cylindrical mate. Let's go ahead and change that to revolute. Click OK. Let's go ahead and add the same joint to this over here. So J for joint, click on the center of this, and then the center of this rod, holding Control, and it locks it in place. Right, so now if we want to see the motion that this will have, you just drag this, and notice how it has, you know, it goes over the boundaries, right? It goes over the contacts, so it's not really respecting the contacts here. What you can do is edit the joint limit, or another thing that you have the ability to do as well is do a contact set, right? So essentially what this is doing is it's preventing the parts from coming into contact with each other. So right clicking on this, selecting a new contact set. Now select the components that you want to have no contact with. So these two components. So now if you note, drag it down and that's where it stops, right? As soon as it makes contact, it stops the motion. Okay, so now finishing off this assembly with this last joint. Again, pressing J for joint, capture the position. Clicking on these cylindrical faces. Now you can do a revolute joint, or you also have the ability to do a ball joint as well, which would represent this a little better. Clicking OK, and then you see that you have the motion there. All right, so now looking at this, you see that we have no grip right here, right, or a handle to cover this this lever. So let's go ahead and add a grip there. Now, one thing to note, again, like I mentioned, is that your main assembly is active. So what you would have to do then is right-click and then create a new component. But let's say that we forgot to do that, right? So let's go ahead and just start a new sketch here on this top level assembly. Let me change the color toggling real quick. Okay. So again, just going over to new sketch. Let's say that we're going to do a line, right? Capture the position. We want on this face, O for offset. Let's drag this out a little bit. Let's do 0.1. Click OK. And then finishing this handle off over here. Let's say that's where we want it. Right. E for extrude. And then do it from an offset plane. Let's say we want it offset 0.1 as well. So then total thickness will be minus 0.444, right? We want to, let's say we want to do a new body, right? Now you do have the option to do a new component, but let's just, for the sake of this this demo, let's just say that it's a body, right? Click OK. Notice now that our top level assembly has a bodies folder in there, right? So we take a look at it, right? We see that it's now a body. So if you were trying to join this with this part, that wouldn't be allowed to do it, or you wouldn't see any joint origins with this body. So one way that you can work around that is by right-clicking it, and then notice that you have the ability to create a component from the body, right? So going ahead and doing that. Notice that now you have that new component. Let's go ahead and name it grip. Let's make this active. And let me just show one thing real quick, right? So then if we click on this component, press V, V hides your components, right? So if you're doing or working with multiple components and you ever need to hide something, V is the shortcut for that. So notice how there's no cut in here, right? So then going back over, modify, combine, the combine function, selecting the target body, our tool body is going to be this, and we're going to want to cut through this, right? Make sure that you have keep tools enabled. Click OK. So now if we go ahead and hide this component, notice how we have the perfect cut of the other component that we had there. Okay, so then adding some fillets to this to make it look a little bit better. Let's see here, 0.15, another fillet here, 0.01. Okay, so now being that it is a component, notice how it's not locked in place, right? So for this, you do have a couple of options. So you can do the joints that we were doing and then just do a rigid joint. You can also do an as-built joint as well, being that if you modeled it on top of the other component, right? So you're taking advantage of the existing geometry that's there in the assembly. But the way that I would approach this is creating a rigid group. So you want this to be rigid with this other component. Click OK. And notice now that these two are rigid, right? So essentially it created a rigid joint for you. Right. Yeah, so notice how easy that assembly was, right? You didn't have, it took a couple of steps away from either using a concentric mates or any of the width mates that you would be accustomed to using. Now, if you do want to add some color to this, because it's kind of boring to look at, right? So let's go ahead and just drag this red over here. If you want to add some color, let's just go ahead and add some color to this as well. Yeah, there's our finished product. Again, it stops on contact, so it doesn't go all the way through your other components. Right. And that's what I have for you guys today. Very nice and quick. Like I said, assemblies do become a lot quicker once you start getting the hang of it. And like I mentioned, the bodies and components, they do make a difference when working with assemblies, right? So being that you have the ability to do multiple parts in a single file, you have to make sure that you're aware of what you want to be a body and then what you want to be a component. We also talked about some of the common practices with joints, right? And some of the different joints that Fusion 360 allows for. One thing I did forget to mention now that we're looking at the summary is how to save that part that we just made, right? So we jump over here back into Fusion. If you right click on the grip, you have the option to save copy as, right? So if you do save copy as, let's just save it as a grip. Save it and then make sure that you know where you're saving it at. Click save, right? So we go expand our data panel real quick. Okay, there's a little bit of a lag here.
Yeah, just gotta wait for it to save and then it should be good.
Yeah, notice how we just saved that grip at 10:20. AM, right? So that's how you would approach saving a new component that you just made. And then again, you can always reference it for any future assemblies that you have or any future models that you might need it for.
Exactly. And the cool thing about Fusion is, hopefully you all know this, that those files do live on the cloud stack. So you can just simply, say Alex finished his model on his laptop here, and Alex has a desktop at home. He doesn't want to bring his laptop home every day. You can just open that file on his desktop without having to carry things like external hard drives, VPN into a network, and things like that. I know those can cause some headaches sometimes. Really easy with Fusion. And how long does it take to install if you don't already have it?
It takes like 15, 20 minutes.
Yeah. Mine installed in 8.5 minutes. Yeah. So, say for example, you go on vacation somewhere, but you need to work on something in Fusion real quick, just go to the lobby of your hotel, jump into like the internet cafe, install Fusion on that computer in like 10 minutes, and you're working.
Yeah.
That's probably like one of my favorite things about Fusion.
The updates as well too, right? The updates are happening in the background. So whenever Autodesk does release any updates, you don't have those long yearly updates that take, that require you to reinstall sometimes the whole software.
Yeah, or run through things like I have to have my IT update this, things like that. Fusion doesn't necessarily have those problems, which is super awesome. Makes it really easy for some people to work.
Right. So at this point, if you guys do have any questions, feel free to go ahead and ask them. If you ever need to reach out to me, my email is alex.alvarez@kativ.com. So if you ever have any questions regarding Fusion 360 or just have some comments about the software, just feel free to reach out to me. I'll be happy.
And if you don't get a response from Alex, you can email questions@kativ.com.
Right.
I know that Alex is sometimes intermittently in here in the office, but you're always checking your email, so no worries. But if you do have more general question about literally anything Autodesk related, go ahead and email questions@kativ.com as well. And we'll be able to answer those when you send us those emails. So make sure you write those down. Or give us a phone call. If you just like Google Kativ, you'll find our main phone number. If you need to talk to somebody, maybe you need a friend. So let's go ahead and answer some questions. So the first one is, if I'm working with Inventor parts, can you save them as a SolidWorks file format once we have all the parts set up? So it's probably more of an Inventor question there, Will, but I can answer that for you certainly. If you're working with Inventor parts in Inventor, you cannot save them out as a SolidWorks file type. You save them out as more a general file type, something like a step file or a Parasolid file that you might be able to bring into SolidWorks later. That did change this year though. If you're working in an older version of Inventor, I want to say like 2016 or prior, and you save it as an Inventor file type, I believe you can open it in SolidWorks straight away and then maintain file links to it with what SolidWorks calls, I forgot what they call it, but it's similar to the AnyCAD functionality in Inventor. If you need to know more about the AnyCAD functionality in Inventor, I actually did a webcast on that yesterday, and I don't remember if you were on there or not. There were actually a lot of people. So if you have any questions about that workflow, let me know. But if this question has to pertain with Fusion, Alex, can you open Inventor parts in Fusion?
Yeah, definitely. You can open Inventor parts. Like I said, the only thing that you're not going to be getting is a design history with that part, but you do have the ability to open that part in Fusion.
I think Fusion's got like many dozens of file types able to open natively in Fusion. Like is with all of the other trends or all the other CAD softwares, when you're using that translator to open those foreign CAD files, you're not going to get things like design history. So you're not going to be able to see the sketches, you're not going to be able to edit the features for say like holes or extrudes, cuts, etc. You're not going to be able to edit those directly unless you're in that native software. It's just how everything works. But at least you're able to open that file. And that's the big thing.
You can also do press pull though. So like if you ever need to do like some quick modifications, use press pull command and then it'll let you do some of those functions. Direct edits
and stuff like that. Along the same lines, if you are familiar with the AnyCAD functionality in Inventor, they are bringing that to Fusion at some point. They said sometime between the next 6 months or later, but the earliest probably in the next 6 months or so. So if you are interested in knowing a little bit more about that, Fusion is really transparent about their roadmap. And you can just Google the Fusion 360 roadmap. They'll tell you what they've been working on, what they are working on. And generally, they're pretty on point with their target goals for releases and things like that. If you want to jump into Fusion real quick here, Alex, and just show us the preview mode for stuff. I know a lot of users aren't too familiar with this.
Yeah, so then if you ever have, let's see. Right, so any previews that Autodesk has released for Fusion, you do have the option to go ahead and select which ones you want visible, right? So notice I do have all of them visible here. Now, a lot of you guys are also asking about sheet metal. Now you can access the beta version of sheet metal. So we go over here, notice that we have the ability to do sheet metal. You do have to sign up for that though. So if you ever need any information regarding that, feel free to reach out to me and I'll be glad to give you those details.
Yep, and it's definitely, yeah, it's super powerful. It's in like the infancy, I guess they're testing it right now. But hopefully we'll see that in the live version here pretty soon. But if you do want to use it now, want to play around with it, or even maybe, excuse me, use it for production, it is available to use at any time.
Right.
All right. Another question here is, if I bring a Inventor model into Fusion, do I keep my constraints?
You don't. Yeah, you don't keep your constraints. So then they all do go away. What you can do though is, again, like I mentioned, use the as built joint. So just make sure that when you do bring it in, you don't move parts around. Keep them as it is, and then go over here to assemble and do an as built joint, and then that'll lock it in place. And then again, if you take a quick look at this dialog box, it tells you what the as built joint is will be doing.
Exactly. Yeah, so that's generally best practice. The same thing goes for Inventor when you're bringing in foreign CAD files. Same thing's going to happen. You're going to lose that design history, those joints and constraints. Go ahead and just build them as is, make them rigid, and you should be pretty good to go. And if you need to do, motion again, it's not too difficult to do that in Fusion or even Inventor or SolidWorks even. So not too bad at all. Lastly, do you guys know what the next Fusion Friday topic is going to be?
We don't. I think it's still kind of up in the air. We're thinking about doing some thermal stress analysis, but that's still up in the air.
Definitely. So we always like to hear feedback from our users. So there is a survey after the webcast, and we do urge you as users, or not users, as viewers, I guess users as well, to go ahead and fill that out. We want to know how we're doing. Any criticism is definitely welcome. Let us know if we suck. Let us know if we're awesome. We just want to know how we're doing. Kind of want to gauge all of that as well. And we do have a section in there for suggesting future topics in Fusion 360. I just want to know if you guys want to start with more basics, kind of what we did today, the assembly environment and stuff like that, or you want to jump into some of the more advanced features of Fusion 360, things like the rendering, things like simulation, and maybe 4 and 5 axis cam. If that's something you want to see, we can prioritize which direction we're going to be going for these webcasts, because there are 2 very distinct ways to go about this, both very different, just based on how comfortable you are generally using the software in your day-to-day work. We'd also like to know what you are using Fusion 360 for. I know Fusion 360 might not be the greatest thing to build a 20,000 part assembly, but if you are using Fusion 360 for something really interesting, maybe for the sculpt environment, creating some of those organic shapes, I know a lot of people are using it for furniture. We'd like to know as well. If you want to share that with us, that'd be great. We just want to know what our users are using it for. Let's see. When is the next Fusion Friday, Alex? If you want to go over that.
Yeah. So the next Fusion Fridays typically are the first Friday.
They're Wednesdays, right?
No, first Fridays of every month, right? So be on the lookout for the first Friday of every month. That's usually when we tend to host these webinars.
Exactly, the first Friday of every month. And if you are in the Southern California area, we did host a Fusion meetup here in the office. Hopefully, I see some people in the webcast right now that did attend. Thank you for attending. It was a really great event. We're going to be hosting those every couple of months, so be on the lookout for maybe an email for something like that too, where we have people come into the office here after hours, enjoy some food and some Fusion 360. I think Alex and Brian did a great job last 2 weeks ago, maybe
2 weeks ago.
Yeah, 2 weeks going over some cam functionality and some of the 3D printing features that Fusion 360 gives you. Last but not least, before I let everybody go, I'll give you another 30 seconds or so to ask any questions you may have. But there is something cool to promote. Let me go ahead and put this in the chat box really quick. All right, cool. So this is an event. Alex, if you want to just go to the chat box and click it so everyone can see it on your screen as well. Just go ahead and exit out of that. And chat right here.
There it is.
Yep, and go ahead and click that link. Perfect. Okay. Yeah, so what this is, it's a Fusion 360 meetup, I guess is what you want to call it, from Autodesk. If you are interested in that workflow, how to transition, I guess, from SolidWorks to Fusion 360, and how easy it is. It really is super easy. I know you traditionally learned in SolidWorks,
yeah.
And you moved to Fusion 360. Your experience was pretty seamless, right?
It was, yeah. It was easy to get used to, and you know, I mean, CAD softwares in general, it's extrusions and sketches, so you do get some of those same functionalities, right?
Right.
So
it's just adding on top of that, knowing where all the buttons are.
Right.
If you want to go to this event, it is open for signups. I put the link in the chat box. Go ahead and click through there if you're in the San Diego area. If you're not in the San Diego area, there's plenty of meetups for Fusion 360 in the LA, Orange County area.
Right.
If you search Fusion 360 meetup, you'll probably get to the meetup website,
right.
And be able to find some really great events. They did one at the Haas.
Yeah, the Haas
Factory?
Outlet Factory in Anaheim. I know Curtis Chan also from Autodesk. He does some at the LA Incubator. So if you ever need any information on that, you know, feel free to reach out.
Certainly, let us know. And Adam, definitely, if you want to see more about mechanical drawings, some of those 2D documentation files coming out of Fusion 360, that is one of the largest improvements they've made pretty recently. That was somewhere I think personally that they were lacking a bit, maybe a year ago, and they've improved that a ton. So we'll definitely go over the drawing environment and what you're able to do within there.